Okay, so I had to muck around with this thing, so there's some erasures, but we got the problem of me tossing a dead battery at the trash can. Okay, and I made up a function that would possibly describe the path of the battery after I released it. And I said, okay, ultimately I said this should be the function, where y is how high it is and x is how far it is. So the parabola would be here on a graph of y versus x. Of course, that parabola would continue even though the battery wouldn't, and the battery wasn't even moving until I released it. So this part of the parabola is not really in our domain, and certainly the part where the battery is below the floor isn't in the domain. The battery might reach the floor if I missed the trash can, which would never happen. Okay. Okay, so, if you know the mathematics, you just can't miss the trash can, right? Why would you miss if you know the mathematics? It just doesn't make sense. Okay. I want to test that one in the real world. It's bound to work out. Okay, so the question is, here's a trash can. And the trash can is, let's say, 1 meter high, just to use nice round numbers. Now, a couple of things about this. If you plug in x equals 0 into this, you're going to get y equals 2. Okay, meaning that when x is 0, this thing is 2 meters high. Now that's a little exaggeration, right there is about 1.8 meters. Okay? If I was a little taller, but we want to use round numbers, just why muck around with 1.82 or whatever it is, right? We're just trying to illustrate this. So, we're 2 meters high, we're trying to hit this trash can that's 1 meter high. How far away does the trash can have to be if this is the function? Well, to analyze this, it's not absolutely necessary to do this, but one of the motivations here was the whole idea of solving a quadratic equation. And generally, your method of solution is going to be you put it into the standard form of a quadratic and use a quadratic formula. Now, if you've already got the function in this form, it's even easier to solve, and we'll do that in a minute. But I want to illustrate what you do in the default mode when you can't factor the thing and when you can't put it in this form or don't want it to go to the trouble to put it in this form, or when it isn't already given in this form. Okay, so we're going to put this in the standard form of a quadratic, which of course is y equals ax squared plus bx plus c equals 0. And well, a quadratic function is the form y equals ax squared plus bx plus c. And the quadratic formula applies to an equation that has the form ax squared plus bx plus c equals 0. Okay? So we first of all put this into an ax squared plus bx plus c form. The way we do that is, well, it isn't in that form because this x minus 3 quantity is squared. We have to square that quantity and then do some simplification. Now, to square that quantity, we don't use superstition. We do what we do in this course. We don't use a special formula that nobody's going to remember correct. Well, 70% of the class won't remember correctly. Okay? We go to what works, which is write out x minus 3 squared as what it means. It means x minus 3 times x minus 3. And then we expand this. We multiply x minus 3 by x minus 3 using the quadratic, using the distributive law. Okay? We don't use that F word thing because it won't apply to anything but binomials. We use the distributive law. Okay? That F word thing is okay when you're factoring trinomials. It's the only place you can use it, but don't say the word in class. Starts with F, 4-letter word, ends with L. Okay, so, and I miswrote here. I wrote a couple of -5s here. Okay, so x minus 3 times x minus 3 is x times x minus 3 times x minus 3. That's a distributive law. And then we apply the distributive law. Should have written x here instead of -5. Okay, we apply distributive law here. X times x minus 3 is x times x, that's x squared, plus x times -3, which is -3x. I originally had t down there, which didn't make any sense, and I didn't write that one back in. Okay, and then minus 3 times x is -3x, minus 3 times -3 is plus 9. Distributive law, two applications. I still have people taking the test and losing points because they leave off one of these steps, or they don't do any of the steps and think they've used the distributive law. Maybe they have, but they haven't shown me, I can't tell, so they're not going to get those points. Okay, so we have this. Now we have to use the distributive law again, don't we? It's all over the place, you can't escape it. Well, we do that. At first we add the two -3x's to get a -6x. Use the distributive law here. Add the 47. We get this, we get the 47, we get this. Okay? That's all Algebra 1 and Algebra 2. So I'm not going to spend too much time on that, but if you have trouble with it, you know where to find the review. Okay. Over here, then, we see that our function could be written this way. It could be written this way. Okay, well, writing it this way, we now ask the question, what is y when x equals 0? Well, I already kind of answered that. If we put 0 in for x here and do the arithmetic, we're going to get 2. And if we plug into this form, it's even easier because we have a 0 for x here and a 0 for x here, and these terms are going to be 0. We're going to be left with a 2. And this isn't 47, this is 2. Writing without thinking. It's 2 here, it's 2 there. Okay. So, we start the clock when this thing leaves my hand. And it travels till it hits the trash can. Okay? How far away does a trash can have to be in order to clear the front of it? Okay? Well, y has to be at least 1 meter. So we set our function equal to 1. And you saw that. You said that. You know that. I think everybody's pretty good with that kind of idea. And I used 47. And I used it in the rest of the thing too. So we're going to have to fix this. Okay? It's not 47. Carelessly wrote 47 down here, and I wrote it here because I was thinking about something else, trying to explain this. Should be able to do both things, but you know how it is sometimes. Okay, so we do this, right? And here's our equation. Now how do we get that into the form where we can apply the quadratic formula? It has to be in this form, so we have to have an equals 0. Well, and you told me, come on, subtract 1 from both sides. Yeah, we do that. And we get something over here, which again didn't make sense because I should have had a 2 here. Okay, that can be put into the form where this is plus 1. Okay? Now this is in the form of a quadratic, so the quadratic form, this is in quadratic form. Quadratic formula applies then with a equal to what? Well, it took a minute to get this, but you know, where do you see a down here? You see it in front of x squared. What's in front of x squared? -5, right? Where's b? It's in front of x, so b is 30, right? What's c? It's the number that you got out here, which I originally wrote as 46 because I was still following my error. Okay? So we get 1. Then we plug all that in. Now, I did the arithmetic with 46 there, it should be 1, which makes that 20, which makes that 920. It doesn't change. Doesn't change things too much. The square root of 920 is about 30.3. Might be off by a tenth there, but I think it's probably accurate, okay? So now we get solutions, just, doing the arithmetic, and you had no trouble with the arithmetic, except you didn't have your calculator. But you knew what to do. You got everything in the right place. You knew it needed to be multiplied, and with your calculator you would have gotten it easily. So we get this. Now, negative 30 plus 30.3 is 0.3. Divide that by 10, you get 0.03. And it's negative 0.03. Now, 30 plus 30.3 is 60.3. You divide 60 by 10, negative 60.3. Divide 60 by 10, you get 6. And it'd be like 6.03, but I'm not even going to bother with the 03. Okay? What does this tell us now? It tells us that this is at height 1, that this thing will be at a height of 1 meter 6 seconds later. Okay? Now, I'm pretty sure that there's no way I can throw this thing so it'll stay in the air 6 seconds. I don't remember what the hang time on my punts was. Okay? But it wasn't anywhere near 6 seconds. And I doubt if today I can throw this chalk at the same angle I could. I wasn't a great punter, but yeah. That was almost useful. Not quite. Okay. And no bad Division III teams. There's no glory in my punting. But I'm just saying, personal experience tells me I'm not going to keep anything in the air, at least today and probably at no time in my life, for 6 seconds. Okay? Maybe an arrow. I probably can't pull, I don't know. Okay. Okay, so what's the point of this? The point of this is that, and there's another problem with that model. Basically, that I'd have to be throwing this thing at about 70 miles an hour at a fairly high angle. But our graph now looks like this. Got a quadratic function. Which hits 2 meters here. It hits 1 meter at negative 0.03 meters. I said seconds. Actually, these are meters, so actually maybe I could actually do this. Okay, anyhow, it hits this at 6 meters, right? It's not 6 seconds. I keep putting time in my feeble brain, okay? So everything I said about not being able to keep something in the air for 6 seconds is true. It's irrelevant to this. It's only got to go 6 meters, which is about 20 feet. I'd probably do that. Okay. Okay. Now, you understand what we're saying. Here's the trajectory. And here's the picture, and it's a familiar picture if you've done the problems, where we have a y value and we want to find the x values. But we're doing it with a quadratic formula. Make sense? instead of an estimate, you know, we could draw the function and we could make estimates. And we could estimate how high it is after it's gone 4 meters. You just come up here and over here, right? So we can solve the equation y equals 1, which is what we have here, by projecting over here and down, and of course over here and down. Okay, so this tells me what my function needs to be. Okay, how high does this thing go? It's the maximum height. Well, where in the graph do you see the maximum height?
2. Or you mean?
It goes higher than that. You know, I gave it an arc. It goes up and comes back down. Where does it hit the top on this graph? Can you estimate where that would be?
Probably 4.
Okay, you think maybe 4 meters? Okay, now actually it's going to be here. Right there's the maximum height, right? Okay, here's the axis of symmetry. Here's the vertex. Vertex is halfway between here and here. Now if I do that, I said it's approximately 6. It's closer to 6.03. Okay? Because of, you know, the 0.3 there. Okay? So what does the axis of symmetry have to be?
Right in the middle.
Yeah, so what's right in the middle between negative 0.03 and 6.03? I'm sorry? 3. Yeah, you add these and divide by 2, right? Average the two numbers. So after it's gone 3 meters, it's at its maximum height. And you have these important characteristics of the graph of a quadratic, right? Okay? And y would be this. Now, am I going to be able to keep it below the ceiling? Ceiling's about 2.5 meters, maybe 3. Okay? Yeah, maybe 3 meters. So does this exceed 3 meters? Let's see. Negative 5 times 3 squared is negative 45 plus 90. Plus 2. Got to go 47 meters high. Well, that's the function I made up. Okay? And I knew from that 30x that it was going to be going really fast that way and even faster that way. So again, we have something that not only I can't do, I can't throw anything 47 meters high. I don't know if anybody can. Okay? It's about 150 feet. So I came up with a bad model. Okay. But still illustrates all the characteristics. And how do you get the vertex of a parabola? The axis of symmetry is halfway between the zeros. So you got to remember, axis of symmetry X equals negative b over 2a. Because negative b is halfway between negative b plus this square root and negative b minus the square root. That puts negative b over 2a halfway between the two zeros.
I'm still terrible at actually solving the
Sorry?
quadratic formula.
Huh?
I'm terrible at solving the quadratic formula.
Yeah, well, you're pretty good at everything else, so maybe you're compensating. Okay, so anyhow, this is what we've got, right? So this pretty much illustrates the most important aspects of a quadratic function and how we can use a quadratic formula to see if we can, I overshot it, hit the trash can. Ridiculous, ridiculous. Hey, this can't go on, for crying out loud. Okay, I give up.